Bonjour buddies, welcome back to another video. Today's first question is, how many positive, even 3-digit numbers exist such that the sum of the hundreds digit and the tens digit equals the units digit? So if we think about it, there are only 4 even numbers that actually apply to this rule. Since 0 does not count in this case because the two numbers in front one would either have to be negative and the other positive, or they would have to both be 0, except that wouldn't even be a 3-digit number anymore, and the negative one wouldn't even exist. So we only have 4. So there are 4 cases in which this number could appear. So if the last digit was 2, if the last digit was 4, if the last digit was 6, and if the last digit was 8. And now we just go through each of these possibilities and solve for how many even 3-digit numbers appear in said 4 cases, Okay, so the sum of the hundreds digit and the tens digit has to equal the units digit. In 2's case, it could either be a 1 and a 1 or a 2 and the 0. Since the 0 cannot be in the front, so it's only 2, 0, no 0, 2. Therefore, there are 2 cases possible for 2 being the last digit. And for 4 can either be, this one is slightly different because now there's a 1 and a 3 and a 3 and a 1. So there's 4, 0, 1, 3, 3, 1, and 2, 2. So there are 4 cases for 4. And it seems like we're coming on a little bit of a pattern here. On 6, we'll have here 6, 0, 5, 1, 1, 5, 2, 4, 4, 2, and 3, 3. And it just so happens that there are 6 cases. 6. So assuming that if you are trying to save time, then you could probably just assume that the last one also has 8 cases, which it does, by the way. So since the last one has 8 cases, we can add up all these cases together. 10, 10, so we get 20. 23-digit even numbers. That the sum of the hundreds digit and the tens digit equals the units digit. Hurrah! Moving on to problem number 2, Tyler has entered a buffet line in which he chooses 1 kind of meat, 2 different vegetables, 2 different veggies, and 1 dessert from the selections below. If the order of the food items is not important, then how many different meals might he choose? So this might look a little bit different than one they just give you the numbers straight out, but it has the same logic behind it. So for meat, he has 1 choice. For vegetables, he has 2, and for dessert, he has 1 choice as well. And since if he's trying to eat meat, then this means that he has 3 meats to choose from, so the first choice has 3. However, since the vegetables, he has to choose 2 different vegetables. Well, he doesn't have to, assumably, because no one's forcing him to eat his vegetables, but he wants to choose 2 different vegetables, as the problem has told us. And since there are 3 vegetables for his first choice that he can choose from. However, since he's already chosen 1 for his first choice, on the second choice, he only has 2 choices to choose from. And for his dessert, he has 4 choices. If we multiply this all together, so 3 times 2, which is basically equivalent to 6, 3 times 4, which is 12, so 6 times 12, which is 72. Final answer, he has 72 choices for his great buffet meal. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Bye-bye!